Hi, and welcome to Microservices. What are they, and why are they so hard to write? A little bit about our agenda. Today, we're going to talk about the definition of microservices. Then we're going to stop and we're going to start talking about the X platform. And then we're going to try to marry these two things together. We're going to say why the X platform is so good for writing microservices. This is a little bit of an advanced topic, so we're going to move right along since I'm going to try to build a microservice, and then we're going to actually see one up and bring it up and watch it run as we would in production. A little bit about ourselves. We are based out of Silicon Valley. We were established in 2008, and since then we've been really passionate about high performance computing. And this is something that continues throughout this day. And you'll see that as we talk about the X platform. So first and foremost, let's talk about microservices. Let's define what they are. I'm sure many of you have heard of the term. It's been pretty prevalent in the industry so far, but what you may not know is that this is just a new name for things that have been around for quite some time, such as distributed processing or agent-based systems or services or actor-based services, right? These are all referring to the same thing. And in order to discuss what they're referring to, it's sometimes easier to discuss what came previous to that. So quickly, what we're going to talk about is a monolithic architecture process, right? So what a monolithic architecture process is, you build out modules or libraries, and they're all assembled into a single application. So in this instance, you're receiving a message within the financial information exchange, and that's being received as a message inbound. We're then normalizing that data. We're then passing that data to the market data engine. That is being passed to the tick data store. That is being inserted into a database. Once that database insert is done, you're replaying the engine. You go into the replay engine because you need to know how to send it out. You do a data denormalizer to figure out who you're going to be sending it to, whether internal clients or external clients, etc. So this is an easy model to build because we're working off of individual projects. Each people and each team are working off projects that are going to, at the end of the day, become assembled into a single component, into a monolithic component, right? And then it's going to be released into production. Now, the question is, what happens when you have a failure, right? What happens when not even one of your pieces of software have a failure, but maybe even an external system like this database goes into a hold? And this is a real example. This is a piece of software that I worked on back in the day where we were going through this entire flow, and then suddenly the database went down. And you suddenly hear the entire trading floor, start screaming and get up in arms. And you see the people who have been working there for a while and have been through this before, they all sort of look at each other and they run away and they go to lunch. Meanwhile, the rest of us are sort of going like, hey, I wonder what the commotion is. And then we end up having to deal with the fact that, a third-party system has suffered a failure, but that is now actually stopping all flow because it gets to this tick data flow and it can't continue. So your entire market data engine comes down. Another thing that people like to point out when they talk about monolithic engines is they'd like to talk about performance, right? So the performance going from each of these boxes is incredibly low because it's on the same machine and it's on the same process. You don't even have inter-process communication, right? You're just passing structures from one library to another. So great, that's a monolith, right? How would we write the same thing as a microservice? And this is how that picture looks, right? We have a connectivity and inbound engine that is receiving the messages from the outside world. It's then packaging that up and sending it to a market data engine that's doing some information, figuring out if it's clean data, if it needs to republish this data, et cetera, et cetera. At the same time that it's sending this to the tick data store, it's also publishing to the fixed connectivity that goes out. Now, what's nice about this particular setup instead of the previous setup is that if I take the database away, yes, indeed, this tick data store may have an issue, right? But the market data engine can continue operations normally, right? It almost becomes as such that the tick data store goes away as well as the generic database, right? Your market data engine is going to continue to work nominally because this is not in the critical path. The critical path, as you can see, is coming down here to the fixed connectivity. So some good things about the microservices, things that we just sort of highlighted here, but I want to bring your attention to, right? So first of all, each of these services are now components, right? And they're organized around functional capabilities. And this means that each component is responsible for doing one thing and only doing that one thing really well. They don't have to conflate different pieces of, you don't have one giant engine working on multiple things, you have a very small engine that's doing one thing. That also, based off of the fact that these are broken up into different products, as you can see that these are not now products and are not projects and are maintained as such, and they're released and monitored into the production ecosystem as products and not individual projects. And that also means that each of these points are getting smarter and smarter, right? Whereas before, if you wanted to add in the intelligence into, how do you denormalize this one particular message that's different from every other message, you end up having to release the entire monolithic architecture. And it's very hard to have all of that intelligence packed into one giant project. It's a lot easier to have that particular intelligence packed into the appropriate module as you're releasing it. And that also means that you've now got decentralized data governance and decentralized data management. And that goes hand in hand with the intelligence, right? As this particular piece of information is becoming more intelligent, it also has to know about the data that it's sending in and out. It's suddenly saying, hey, does this individual piece of message that's flowing through my system, does that make sense from what I know about the world, versus just assuming that a downstream piece of software is going to make use of that information and know what to do with it, so I can just pass it off. And as I previously alluded to, is these systems are designed for failure, right? They're designed for individual modules to go away, and they are incredibly resilient. You can even have separate modules fail at different times, and the overall system, or the core part of the system, is going to continue working, right? The only time that you're going to have a hard time is while you're receiving data and you're still doing your work, but you're not able to send this out to your clients. That's when you notice that there's a primary problem on the or a problem on the primary path, right? These systems are designed for failure, and you just have to realize, you have to put some thought into what projects or products, I apologize, or what products are on the critical path, so that we can understand when something is going to affect operations more deeply. So this is the good parts of microservices, right? Let's talk a little bit about the bad. As I'd mentioned before, the good side, the good things of it is the data, decentralized governance, and decentralized data management. And you'll notice that it's also on the bad slide, right? This is definitely one of those double-edged sword situations. It's very nice that the products have to be more intelligent. It's very nice that that intelligence has to be baked into the product and that it has to know what it's doing. But it suddenly becomes the burden of the developers who are working on that product to know about the stuff that's going on as well. Whereas before, people were very happy to say this is this information is going to be consumed downstream, so it doesn't matter if it makes sense to me. Now it does matter. Now you have to pay attention to that, right? Because we are breaking things up into different products, we may have latency concerns depending on where those products live. Those products may live in different data centers, they may live in different regions of the world, and if they have to communicate in order as an ecosystem, in order to get an entire process done or a transaction done, that's going to introduce latency. So you have to pay attention to how you're designing your ecosystem, how you lay out the modules that you're going to be building. And then another problem is that you have to manage multiple projects and deployments, right? So it's nice that they're different products. It's nice that you're not all working on one giant piece of code, but this makes DevOps life a little bit more difficult. They now have to manage not one piece of software, but 5 pieces of software or 10 pieces of software. And profiling those 10 pieces of software isn't exactly that easy, right? If you have to skip from machines to machines, if you want to see if there's a slowdown, are you able to figure out if there's a slowdown in the entire system? And does that mean that there's just less messages flowing through? Or does that mean that there's a problem with one of your current releases and that needs to be rolled back, right? And that sort of leads us nicely into stepping through errors on distributed logs becomes difficult, right? If you have to move from machine to machine and you're looking at the granularity level of microseconds or nanoseconds, you're going to have to contend with clock skew. So it becomes a little bit more difficult. You can't just look at your log level and see an error at 12:01:53, because it's much more granular than that, and the clocks on the machines may not always agree. Even if you get the most expensive clocks out there, the GPS systems, right? They're only good to about a millisecond of syncing up. So that's something that needs to be dealt with as you're designing your system. And then one of the old style a holdover from the old style of development into the microservices world is people just like to replicate messages. They say, oh, well, we're just going to publish out the same message 12 different times because, you know, all 12 different people need it. And that's not true. That's actually a fallacy, and that's a problem on how you're designing your system. So that message explosion is something that you need to keep an eye on. Overall, microservices as a technology are very chatty systems, and that's good. You want very chatty systems, but you don't want it to be chatty with redundant information. You want to be sending appropriate information across the wire. Another thing that becomes more difficult in the microservices world is you're now dealing on distributed transactions, right? And that means that you've got one message maybe affecting 2 or 3 or 4 different products, and all of those products have to work with each other. And then lastly, I'm going to jump to tools. I mean, I've said on several occasions that you want to have your individual microservice doing one thing and doing it well. And that's a lot easier said than done, because that means that you have to integrate with messaging, you have to integrate with logging, you have to integrate with your entire ecosystem so your DevOps can monitor and maintain it. You have to be able to provide administrative commands so that you can control the system, right? And without a system, without a platform to provide you all of those details, you're going to have to implement them yourself. So that's definitely another particular issue that you have with microservices. So we've talked about some of the good things about microservices, and we've also talked about some of the bad things of the microservices. So let's talk about what the microservices absolutely require. If you're going to build it, these are the things that you need to worry about, right? So your microservices, they need to be performant. You know, as the world gets more and more, gets bigger and bigger, and the world has more and more data, you know, we're not processing 10 messages a second anymore. We're not processing hundreds of messages a second anymore. We're processing thousands, tens of thousands, or even hundreds of thousands of messages a second, right? We also need to be able to scale. A lot of times people will build out a microservice as a proof of concept, and then, as everyone knows, proof of concepts have the ugly habit of becoming production. And, you know, that proof of concept, you need to be able to scale that out to the production level technology, or the production level messages and requirements that you see. And you need to be able to do that without having to redesign your entire service. You also have to be able to deal with versioning. As I'd said, because we're now releasing each of these components as individual products, right? You're now going to have to be able to deal with versions in between these components. And how do you deal with different message versions and different logic versions and different everything else? So that's something that you need to work in. And as I mentioned before, we don't want to be sending the same message. We need to avoid message explosion. So whatever platform you're using needs to be able to support that as well. Also, microservices are the way that smart cities are being built, and the way that emergency services are being integrated into those smart cities, and the way that your phones are handling everything. And that means that you have to have 100% reliability. As these services become more and more integral to our way of life, we can't suffer an outage. We can't say suddenly the police band is going to be down for 10 to 15 minutes while we're deploying our microservice management because, you know, we didn't design it well enough. We also need to analyze the messages and scale of what's passing through your ecosystem. You need to understand that not just the amount of messages, but the kinds of messages, to understand what the flow looks like and what the shape of that flow is, so that you can address it appropriately. So you can identify those outstanding business issues, and so that you can identify higher regions of, you know, a police presence, for example, or fire presence, for example. And because we're dealing with this, with each of these things as products, we have some of our clients that deal with, you know, 2 or 3 or 4 microservices, and that's not too bad. But we have other of our clients that deal with 300 or 400 microservices. If you're trying to deploy these things by hand on a case-by-case basis, that becomes a very difficult process. So you need some kind of enterprise deployment capabilities. Now, microservices, we're moving to this design because of the reliability that they provide, because of the performance that they provide. And these are the absolute musts that you have to have for the microservice, for any platform that you're going to deal with microservices. Great. So moving right along, let's pivot now, and I want to talk about what the X platform is. So the X platform is a memory-oriented platform for building multi-agent transactional Java-based enterprise applications. And that's a statement. You know, I'm jealous of some of my colleagues are able to say this with such gravitas and seriousness that people nod their head wisely and say, yep, you're absolutely right. We're going to go that way. And I'm just not one of those guys. So instead of trying to describe what the statement is, I'm going to talk about what that system does with pictures. So the first thing to know is that we're a message-driven system, and we get a whole boatload of benefits when you're a message-driven system, but I'm going to talk about 3. And the first one is we get routing capabilities. We get some very advanced routing capabilities to where we're able to not only specify what kind of message you're sending, but specifically who you're sending that message to. And if you're running within a cluster, you can specify instances of within that cluster. And we're going to talk about how we do that a little bit more. We've also abstracted away the difficulty of dealing with messaging systems, right? So there are a lot of different messaging systems out there. There's Kafka, there's ActiveMQ, there's TCP, there's TIBCO Rendezvous. There's just tons and tons of them out there. And being able to switch between them and being able to understand the difficulties of each individual messaging system becomes quite complicated. And we abstract that away from them, and we provide you the ability to just fire and forget. We have the same messaging system across all different providers, and we have guaranteed the same functionality across all different providers. So you're able just to say, send that message, and we guarantee that it's going to be getting to where it's going. We also guarantee exactly once processing in this fire and forget. And that's important when you're dealing with state management. That exactly once processing makes sure that you don't, in the event that your system is having an issue, you don't charge that credit card twice, right? Or you don't buy that stock twice. And then lastly, we co-locate your business logic and your message handlers. The X platform is a low latency platform, right? So we really don't like having a lot of these abstractions and indirection layers, because that just adds latency to your system. So we really bring your business logic as close to the message handler as we can, and you can't get closer than being inside it. The next thing to talk about is that we're a stateful system. We keep relevant information in state, and we do that by letting you keep local plain old Java objects, local POJOs. Now, one of the reasons people don't like keeping state in general is because of that volatility, right? You say, if I keep stuff in memory and then I suffer process loss or machine loss, I lose where I am. So our system is highly available. And once you realize that our system is highly available, we've basically made state and we've made memory durable. So these 3 things combined, the fact that we're a message-driven system, we're a stateful-based system, and that we're highly available, makes you able to write your state changes direct to memory with the same confidence as you had if you were writing directly to disk. Now, not surprisingly, based off of the title of this webinar, we're multi-agent, or we ask you to provide things in microservices, right? And that means you do the one thing and you do it well, right? And again, I alluded to, this is easier said than done, because you need the administrative commands. You need to be able to communicate with different processes over messaging systems. You need to be able to handle state, and you need to be able to be highly available. And as I've mentioned on this slide alone, that's what the X platform does. That's our bread and butter. We're also able to do all of this while being highly performant. People, whenever I say highly performant, people almost immediately ask me to qualify that. So I've stopped waiting for the question. I've just started qualifying it right off the bat. Some of our Wall Street clients are dealing with hundreds of thousands of messages a second, and they have a response time in the tens of microseconds. And lastly, we provide horizontal scalability. In general, the horizontal scalability looks like most people will abstract that horizontal scalability based off of this message flow alone, but it's such a large topic and it's such an important topic that I dedicated the next slide to it. So the way that we provide this high availability is this, for every partition that we're up and running, we have a primary and a backup, right? We have a primary and we have a backup. And this primary and backup is using pipeline message replication, i.e. TCP and RDBMS, to communicate with each other. So it's not going over the same messaging provider that people would be using, such as Solus, Kafka, or any of the JMS systems. We're keeping each of these states are 100% private. This is private to its own partition. So you don't have any of this contention between partition 1 and partition 2. And that's historically one of the largest contributors to latency, right? Is this contention of trying to figure out that I can write to this piece of state while somebody else isn't writing to it as well. Not only that, we stripe our data out by partition, and we provide you content-based routing. That means that not only is your messaging system built with intelligent topics based into the configuration, but we're inspecting each of the messages to figure out where that is being routed to. So we provide this smart routing capability, which allows you to target an individual instance in a cluster of systems that are up and running. You're able to target an individual partition of your cluster. And as I'd mentioned before, we try to make the messages, messaging becomes transparent. This all becomes a matter of configuration as well as inspecting the messages. And we're providing you, we take away that contention between partitions, but we also take away the contention between concurrency. We do all of this stuff in a single threaded methodology. Great, so hopefully now we can talk a little bit more about when I say that the X platform is a memory-oriented platform for building multi-agent transactional Java-based applications, we understand more what that means. The only caveat that I would throw into it is that we're performance-centric. We really, really care about latency or how to avoid latency, I guess is a better way of saying it. Now, in general, when you work on an X platform, this is basically what it looks like, right? You have your state that is managed up here by us, but accessible by you via normal Pojo getters and setters, right? And you are the one building this layer here. This is your domain-specific information. This is that black voodoo magic that you and only your company knows how to deal with, and you're sitting on top of this X runtime. And this X runtime is itself sitting on top of an asynchronous guaranteed messaging bus, right? This X runtime is responsible for guaranteeing exactly once delivery. It's the one responsible for the subscription management, for sending and receiving messages. It's also going to guarantee that you're always running in a primary backup mode. And again, you don't have to worry about any of these quality of service issues. You only have to worry about that domain-specific logic. So in general, this is what an X application looks like. So I'd like to give a quick example of one of the POCs that we ended up doing for one of our clients, and that later they adopted, went from a POC and moved it into production. But when we started out, they were doing a credit card processing system, and that credit card processing system was receiving requests. That request would go to your credit card master. It would then look up stuff from a database, do some calculations, and slap the results in the database, and then send it to the merchant master, which would then look up its information from the database as well as the response from the credit card master, correlate them, do its own information, and slap it back into a database, and so on and so forth, until it would finally get to the end, and you would have a request or a response in either the affirmative or the negative. Now, the first thing that we did is we broke these out into microservices, right? Because we're now paying attention to individual functionality of what that microservice is doing. And because we broke that out into individual functionality, we're able to scale these guys out differently. Now remember, all of these are running with primary and backup mode, but that cluster is scaled on a different metric than the merchant master is, for example. So the credit card master, we can end up having 25 different instances of it because these are scaled out by person, where the merchant master only has 5 instances because they're scaled out by merchant. So it suddenly becomes available for you to target the information that you're dealing with, or that your specific function needs to deal with, and cater how you're going to build that particular project out to that information, instead of having to do the best you can with the information that you have. The other thing to point out is because we have content-based routing, we're then passing that message. We're not passing it to the entire cluster and saying, hey, figure out which of the instances this message belongs to. No, we're looking inside that message, and we're passing it specifically to the instance that it belongs to. Therefore, you can immediately begin processing. Again, it's a matter of latency, avoiding those extra checks, avoiding those extra hops, and not polluting the rest of my instances with unnecessary messages. Again, that's the message deduplication that we spoke of earlier. And something else, because we support many-to-one messaging model, right? Whereas before the request was happening in serial manner, we're now able to process these things in parallel. That means that originally what we were competing against was the latency of this system is the sum of each of these steps, whereas the latency of the microservices approach is the max of any one of these individual instances, right? So while it may appear that you end up having more instances running, you've actually vastly reduced the latency of the overall system simply because of how you're dealing with messages and how you're dealing with information. And then last and most important, well, not most important point, but last and another important point is you can add things in later. This means that you don't have to sit down and design your system and figure out what your system is going to be doing, a year from now, or 5 years from now, or 10 years from now. You can tack things on as they become available and as they become necessary. It's actually incredibly common for people to design a system and then notice that there are side effects and notice that you can take advantage of those side effects, that you hadn't thought about additional information. And suddenly the designers have to stop and they have to rebuild the entire system or rebuild the entire architecture. And that's not true with this paradigm. You can add things on dynamically and try them out on a lower user base or on a lower message base. You can try them out on 1% of your message flow, or 5% of your message flow, or 50% of your message flow. So you're able to do incremental releasing or testing. And the reverse is also true as well. As it's time to decommission things because you've either upgraded or stopped using that particular product, you can decrementally release, right? You can retire things gracefully instead of just doing a turn off. Now, this next slide, if you guys have been watching the news in the last year or 2 years, you'll notice that security is a big thing, right? Everybody seems to be getting hacked or dealing with hacking attempts. So this is such a complicated issue and such a long talk that I basically have an hour-long webinar that we can talk about this. So I'm going to just jump over it. But I like to just mention this slide so that you know that it's on our radar. This is something that we are very cognizant of, and we provide you the capability to securely build out any of the projects or processes that you need that are going to be communicating either over long distances or within a closed circuit system. Security is paramount in our mind as well. Something else that I'd mentioned is that we provide the ability to do zero downtime upgrades. And the way that we do that is if your system is up and running and you're ready to do to have a release, we knock down the backup. We upgrade the backup. Then we bring the backup back up. And at that time, we knock down the primary, which means that the message flows fail over to the new version of the backup. And then we bring the primary back up, which will sync. And now you have all applications up and running with a zero downtime approach. So this is one of the many ways that we support zero downtime approaches for maintaining 100% reliability and 100% 24/7 uptimes. Excuse me. This is actually one of my favorite slides, and it's because I mentioned, developing things in a vacuum is quite difficult, right? You need to be able to understand what's going on in your entire ecosystem, and you need to be able to understand what's going on in your individual process as well. And that means that you need to be able to measure things that's happening within your process or across the ecosystems as well. And we give you just a large amount of visibility into what's happening on both the micro and the macro scale of the system. So we provide you these statistics out of the box where you're able to compare how long message processing takes, how long storage commits takes, how long it takes to send stuff. We take things all the way down to the granular level of being able to see how long it takes us to unmarshal the message. In other words, how long it takes us to receive the message from the wire, right, and then translate that into a POJO. We can tell you how long that takes because maybe your messages are too big, or maybe that's not part of the problem that you're looking for. But we give you unprecedented clarity into what's happening on your individual processes as well as your entire ecosystem here, right? So we provide you the ability of managing and deploying and maintaining your entire ecosystem through our product called Lumino, right? Lumino allows you to upload and deploy to your entire system. It allows you to execute commands. We're going to talk about that in a little bit. And it allows you to see exactly what's going on individual machines or on individual processes, right? You can see how many messages you've received. You can see how many messages you've sent. You can see the flow of the message, right? You can see how the input to offer poll is taking, right? You get an unprecedented amount of clarity into your system. And what's more, we provide these statistics to you you can add these statistics dynamically into your system so that you can keep track of any of the information that you want to keep track of as well, not just the metrics that we have found important when building out this platform. And our Lumino system also provides you, or our Talent system in conjunction with Lumino, sorry, provides you the ability of providing these administrative commands or these command handlers. And what that means is you can annotate any of the methodologies or any of the methods within your systems with the command handler, and that allows you to expose that method via Lumino in order to do administrative commands. So for example, if you build a checking system, you not only need to be able to debit and credit from that checking system, but suddenly, you need to be able to add users, remove users, freeze users, do things of the sort, right? Under normal circumstances, you would have had to build out those administrative commands. You would have had to create a separate client. You would have had to create a separate access control. You would have had to do all of those things, whereas we provide you that ability by a simple use of a single function. Great. This is usually where I ask for questions, but since it's a webinar, I'm going to skip over that part. I'm going to try to get our feet wet a little bit, which is why I've been rushing through this. I'm going to try to show us a little bit of code. And so let's talk about what we're going to build quickly. What we're building is going to be a multiplier. And what that multiplier is, it's receiving information from this sender, and that's just going to receive, a number that I'm going to call it the left-hand side and the right-hand side. That information is going to be sent to the multiplier, and that multiplier is going to multiply it, and then it's going to send it to the receiver. After it multiplies it, we should probably just kick it in a message store so that we can keep transaction history. And also, since this is a microservices approach, and since we are using the X platform, we should make this completely redundant. That means that we have a primary and a backup up and running, right? And then we need to be able to test that if we knock out the primary, the sender is going to fail over to the backup seamlessly without any integration or any manual input from the users, i.e. you guys. Okay, great. So let's try to get to it. I have this thing built out, and what I'm going to do is just walk us through the individual pieces of it. So we have we should start out by looking at the messages that we'd mentioned, right? We said we're going to be sending a message with a left-hand side and a right-hand side. And I've taken the liberty of calling this the multiplication message. Try to be as verbose as possible, right? And what's going to be outbound, right? If we remember what the multiplier is going to be sending out is going to be a result message. And that result message should have the result of multiplying the left-hand side and the right-hand side. And we need to be able to tie these messages together, so they should be sharing the same ID. And then I said we also wanted to keep a history. Right, so we want to keep a history of those operations, and that means that we want to be able to tie them together by message ID. We want to remember what the left-hand side is, what the right-hand side is. We want to remember what the result that we sent out is, and then we want to look at the time that we did this, so we can have some kind of metric on it. Right, we want to keep these things in a queue, and that queue should be organized inside my primary repository, and that's it. We've sort of built out our data model right now. So if we flip over to the application, this is where things usually get more complicated if you're starting to use messaging systems and state management systems. But you'll notice with us, it's actually quite simple. You literally have one message handler, and that message handler is sending you that multiplication message. And surprisingly enough, that is exactly what it looks like in the XML, which is the application data modeling language, right? And not surprisingly, again, we're past the repository, right? And that repository looks exactly like the repository that we have here, where I'm actually keeping a historical operations, right? So these things I'm trying to point out, they map one-to-one with the states and messages that that we're building out in our models, and then they get exposed exactly as POJOs running in your system. So in order to build a highly available system, in order to build a primary and backup, that's it. This is it. This is the whole shebang, the whole piece of code. So I think it's 81 lines of code, and we're able to do all of that particular logic as we want. As you can see here, I'm creating an operation. I'm copying in the message ID. I'm copying the right-hand side, I'm copying in the left-hand side, I'm multiplying the right-hand side versus the left-hand side, I'm keeping a copy of it as we described. I've also decided to keep a min and max of any of the results that I have, and then we're sending out a result, right? We send out this message saying, here's the result message, set the actual result of the operation and set the message ID and send it out. And then usually I don't do this because it's a very, very latency expensive operation, as I'm logging stuff out. But because this is a tutorial and I'm trying to show you guys how easy it is to write it, I felt that it's probably okay just to do that now. So great, if we pop over to our terminal, I have I've taken, I made sure it ran, and let's just create ourselves a new window. Let's do one for the sender, and let's do green for the receiver, and then let's do a teal window for my backup. Great. So I got enough windows up and running. Now, in general, you know, we don't really advise people to run all of these things off of your laptop, simply because it's the best way to do integration testing, right? With the primary and backup is out of a lab. But it's nice to show that number one, you can run it out of your laptop, and then number two is, you know, you should really do your individual functional testing from JUnits. But like I said, this is a demo, so we're just sort of skipping over that parts. So let me move into these the appropriate places. And these are the processes that I have available to me. So I'm going to bring up my my receiver first, and then I'm going to bring up my primary node, and I'm going to bring up my secondary node, and I'm going to get my sender ready. Now, while this is booting up, let me just show you a little bit of what my receiver is doing. I don't have any fancy logic in there. All I have it doing is receiving the message right now and keeping a message count, and then I'm printing out the message ID and the result. So we should know pretty much what that looks like. And the same thing is true for the sender. I am basically just, well, let me just walk you through that particular code right now. Sorry, the sender. So all I'm doing here is I'm creating a new message. Then I am creating a new random right-hand side, a new random left-hand side, and sending that message out. So as you can see, oops, that was another demo. As you can see, these things map one-to-one on the messages that I'm sending here. So I think that's it, and the system should be booted up perfectly. Oh, it is. And let's run let's run the sender. Woohoo! And here we are. We can see messages are being sent, messages are being received, they're being multiplied, and they're being received from the sender. So right there, we now have IPC, right? We have inter-process communication. We can distribute this process pain-free and incredibly easily into different machines. But here's something more. I'm going to rerun this experiment, and I'm going to show you that we've also got high availability, because as this is sending, I'm going to go ahead and kill this primary instance. And you're going to see that things failed over to the backup and they continued working seamlessly. Now, it failed over a little bit slow because I'm running this on JMS, and it failed over a little bit slow because I'm running this entire thing on my laptop. When you are running these things out of the system out of Solus, our failover is in the microseconds. So we're, like I said, we're very, very cognizant of the latency requirements of our clients. And then just to show that this comes back up, I'm bringing up one more client, but as what I'm trying to show here is that the backup will stay running as the primary as soon as this guy boots up, right? It doesn't try to flip it back. It just intelligently flips between them. And so it intelligently flips between them and helps you manage this this whole process. And that's it. I see we're coming up on the 50-minute mark. I always like to try to leave some room for questions. So I'm going to go ahead and stop sharing, or leave the screen share, I guess, and pass it off. Does anybody else have any questions?
Thank you, Kevin. So
Happy
we
to do
do
it.
have, yeah, we do have a couple of questions coming into the queue. So let me go over those with you real quick. So I'm trying to there's a couple of these that I can put together. So I'm going to put a couple of these together for you so you won't have quite so many. Okay, these two kind of go together. The first question is, does the platform you were just showing support deployment as well? Can we use Docker and Kubernetes with it as well?
Absolutely. The platform we're showing is it's Java based, right? It's you support deployment locally into the cloud, and you can use Docker's, Kubernetes, or any other tools that you want to use or that your DevOps are already using. This integrates with pure Java, so any tools that are surrounding pure Java are usable.
Great, thank you. The second set of questions I'm going to put together: what clouds does it support, and how do you handle, and what code changes are required between shifting from on-premise to cloud?
There are no code changes required from on-premise to cloud. That's sort of the whole point of the platform, right? Is we abstract away that difficulty of message communication and how to have each different process communicate, and we support all clouds. So, like I mentioned for the previous question, this is a Java-based system. So as long as the system supports Java, you're going to be able to run this particular system. So that means Azure, AWS, the Google Cloud, all of these systems are supported out of the box.
Great. And this last question, I can take it for you. The question is, how do you get this product? And what's the price? So the X platform, if you go to the Neeve research website, you can download the product. There is a free version and open source to go with it, open source support. There's also a support that's available, of course, for through our subscription basis. But yes, it is available, and you can easily access it off of the www.neveresearch.com website. And that's all the questions we have for today. We did post a couple of different polls and questions during the session. So if you haven't already done so, we would appreciate a quick response to the content polls and to did the session meet your expectations? And we appreciate you joining us today. Thank you again. Thank you, Kevin.
Thanks, guys.